Good morning, guys! In this video, we are going to discuss the general form of quadratic function, which is y equals ax squared plus bx plus c. We can actually rewrite this in vertex form to identify the key features of its graph by using completing the square, which is not actually very new to you. Take for example, y equals 2x squared minus 16x plus 5. So first, we need to make sure that the coefficient of our quadratic term is 1. So we can factor out 2. And that's going to be x squared minus 8x close parenthesis plus 5. So remember, we only factor out the 2 from the quadratic and the linear term. Next, we complete the square. So our linear term's coefficient is negative 8, so we divide it by 2 and then square the answer. So that's going to be negative 4 squared, which will give us 16. So that means we have to add 16 to x squared minus 8x. So that's going to be x squared minus 8x plus 16. And of course, since we added a 16, that means we have to subtract 16 times 2. Now, why do we have to subtract 16 by 2? Remember, we factored out a while ago a 2 from the expression inside the parenthesis. So that means if we added 16 inside, we have to multiply that by 2 and subtract it outside the parenthesis. So that's going to be minus 32. So why do we have to subtract instead of add? Remember, we want to retain the original value or original form of the expression. So that means if we added a 16 times 2 or 32, we have to minus a 32 to make it a zero pair. So next, rewrite it by factoring the trinomial. So that's going to be 2 times, or y equals 2 times quantity x minus 4 squared minus 27. And there you have it. We already have our vertex form. So we can already tell what our vertex is. And what is our vertex? That's going to be 4, comma, negative 27. So aside from this, there is another way to identify the vertex. Remember how the roots are also called x-intercepts? So just to illustrate, if these are our x-intercept, let's say the graph is over here. If these are our x-intercepts, how can you determine the location of the vertex? Okay, that's right. It's actually in between the 2 points. So somewhere over here, in between the 2 points. So we can actually find the x-coordinate of the vertex by getting the midpoint of the 2 roots. So can you do a quick recall as to how you can get the midpoint of 2 numbers or 2 points? Okay, that's correct. You have to get the sum of the roots and then divide that by 2. Now, doesn't that sound familiar? Sum of the roots? Isn't it? We learned that in our previous lesson. And what is the formula for sum of the roots? Okay, so it's negative b over a. So if we get the sum of the roots and divide it by 2, we'll be able to get the midpoint. So we just have to divide this by 2 and we will get negative b over 2a. So using our previous example, the same example, y equals 2x squared minus 16x plus 5. So if we will substitute the values for negative b, that's going to be negative of negative 16 divided by 2 times 2, which is the value of our a. And we will get 16 over 4, or simply 4. And there you have it. We already now have the x-coordinate of our vertex. Now, how do we find the y-coordinate? Can you think about it for a few seconds? Okay, correct. You just have to plug in the value of your x-coordinate to find your y-coordinate. So we just do y equals 2 times 4 squared minus 16 times 4 plus 5. And that's going to be 2 times 16 minus 64 plus 5. And after you simplify all of that, you will get negative 27. And isn't that also the value that we were able to get from a while ago? So how about the other key features? Now, let's look at our equation again. Y equals 2x squared minus 16x plus 5. Now, since A is positive, then we can say that our graph opens upwards. And of course, the axis of symmetry, we just have to look at our vertex. Since the vertex is 4, negative 27, that means the axis of symmetry is equal to x equal to 4. How about the domain? Of course, the domain is quite easy. That's simply negative infinity to positive infinity. And for our range, since our graph opens upwards, then that means negative 27 would be the minimum point. So the range would be from negative 27 going to all the positive values of y, making our range negative 27 to positive infinity. Now, what else are we missing? Oh, we need to find the y-intercept. So how do we find the y-intercept? So we just have to plug in 0 to x. So that's going to be 2 times 0. Okay, I forgot the y. Y equals 2 times 0 squared minus 16 times 0 plus 5. I think you know where we're going at, and that's gonna leave us with 5. So that means our y-intercept would be at 0, 5. If you want to check your answers, type the equation in Desmos and double check if you were able to get all of our answers correctly. Okay, so now of course it's always your turn this time. Try to use any of the two methods you learned and list down the key features of the graph of the given equation. So I want you to try y equals x squared minus 4x plus 2. So you can use either the completing the square method or the one where we use the midpoint of the sum of the two roots. So that means, okay, now so let's check if you were able to get the correct answers. So let's use the second method that I taught you, which is to get first the midpoint of the roots. So the formula for the sum of the roots is negative b over 2a. So that's for the midpoint of the sum of the roots. So that's going to be negative of negative 4 divided by 2, which is actually equal to positive 4 over 2, or simply 2. So now we have the x coordinate already of our vertex. Second, find the y coordinate of the vertex. So we just have to plug in 2 in the equation. So that's y equals 2 squared minus 4 times 2 plus 2, which is going to give you 4 minus 8 plus 2, which is simply negative 2. So now we have our vertex at 2, negative 2. So the rest is of course very easy. From our vertex, we can get our axis of symmetry from the x-coordinate. So that means our axis of symmetry is at x equals 2. Of course, since the coefficient of our x squared is 1, that means our graph opens upwards. Its width is the same as the parent function, obviously, since the coefficient is 1. The domain, of course, is quite easy. I think this one is the easiest. It's from negative infinity to positive infinity. For our range, since the graph opens upwards, that means for our y value, that's going to be the minimum again. So that's going to be negative 2 going all the way up to the positive values of y. So that's negative 2, comma, positive infinity. Now for our y-intercept, let's solve for it again. So that's going to be y equals, plug in 0 in our x. So that's 0 squared minus 4 times 0 plus 2, which gives us, of course, obviously just 2. So our y-intercept is 0, 2. And there you have it. We're done. So I hope that you were able to learn how to find the key features of the graph of a quadratic function using this tutorial video. If you have any questions, don't hesitate to ask your teachers. Bye!